We started off by cloning the repo to a Mac with Docker installed. We then built the Chart app test image and pushed it to a Docker repo in GCP. Next, we stood up a Linux VM in GCP running CentOS 9 and installed gcrane into user local bin. And finally, we cloned our repo to our Linux demo host and added our repo's source directory, the directory where all the bash scripts live, to our path environment variable. Running the Docker images script on our demo host shows that we have no images stored locally. So let's run the Docker pull script to pull our Chart app test image to our local host. Our Docker pull script uses gcrane to interact with our GCP repo and pull the image locally in OCI format. Our script then does a bit of post-processing on the local image to make it easier to quickly transition the image into a running container. Once the Docker pull is finished, we rerun the Docker images script and see that we now have the Chart app image on our demo host. Next, we'll open another console window where we'll run our Docker run script. The script will create and start a running container in the foreground. The Docker run script takes 3 command line arguments: the name of the image to create and start a running container for, the maximum memory footprint the container and all processes inside it must fit in this case 800 megabytes, and the maximum amount of a single CPU all processes inside the container can consume, a number between 0.1, 10%, to 1.0, 100%. The Docker run script mounts the image's file system layers as an overlay.fs file system, sets up the environment to match the environment in the image's metadata, and it creates a C group to limit memory and CPU consumption of all processes in the container. Finally, it executes the entry point of the container, placing the entry point's PID in the new C group. Now that our container is running, let's go back to our other console window. Running Docker PS shows that our Chart app container is running and has a unique identifier, or container ID. This ID will be used as an argument to other commands to uniquely identify this specific instance of the container. Next, we'll use our Docker exec script to execute commands inside the running container. This is achieved by leveraging the nsenter command. We can use ls to look around in the container's file system. We can even run bin bash to open a console window inside the running container to explore even further. Pretty cool, huh? Now let's point a browser at our Chart app to verify our container is functioning correctly. Our Chart app graphs the last 6 months of a company's stock price, along with a couple of moving averages and technical indicators. Let's use it to take a peek at NVIDIA's stock price. How's IBM doing these days? Looks like everything's working correctly. Let's go back to our console window. Now let's pause our running container. Our pause script does this by leveraging the C group freezer controller. Now that our container is paused, let's go back to our browser and try to interact with our application some more. Let's try to chart NVIDIA again. When we hit return on our browser, it just hangs, and it will eventually time out because our container has been paused. Now, let's unpause our container and then go back to our browser window and try and chart NVIDIA again. And just like that, our container is functioning correctly again. Only thing left to do now is to kill our container. And for that, we'll use our docker kill script. After killing our container, we rerun the docker ps script and we see that we no longer have any running containers on our machine. If we make one last attempt to interact with our application from our browser, we'll find that it's no longer running, as expected. I hope this repo helped you gain a better understanding of how container runtimes perform their magic.